In this video, I'll be working through an example dealing with cross products and dot products. And in the last video, I talked about how we do both of them and where they apply to a problem. But in this video, I'm going to be applying it specifically to an example to help understand. So what we're looking for is we need to find the moment along AB. And we're given A, B, C as a pipe. We're given the distance in the I, J, and K parts of those. And what we need to find is the moment along just this part. And we're also given the force. So in the last video, as we talked about, how we find the moment along a specific part along AB in this example, right here, is we need to find the direction of AB, and we're going to take that in dot product with the moment created from C. So in this example, AB we can find because we have the I, J, and K apart from it, but MC, we aren't given MC yet, we're only given FC. So we need to find MC. That part we know we can find the moment at C because we're given the R from our rotation point. This pipe was connected at a wall, so I should specify that our connection point was at A. So we need our distance in, this time in cross product, not dot product, in cross product with our F of C. So that's the two equations that we need to realize. We need to realize the moment of AB is created by the direction of AB times the moment on the system. Then we need to break down the moment of the system given our force and the distance that it is from our point of rotation. Those two seem to make sense. So we're going to break this down then. Our U of AB, we know that that is I, J, K over the square root of I squared, J squared, and K squared. So in this case, our direction of AB, we don't have a C direction or a K direction for just AB. So all we're gonna have is 2 plus 3 over the square root of 2 squared plus 3 squared. And technically we'd have zeros out here for not having any K's. So this is equal to our U of AB. This part would go down here. Then we need to have our R and our FC in order to find our moment at C. So our R is simply 2, 3, and 4. That's the distance from our point of rotation to where our force is being applied in IJs and Ks. Then we need to find the force at C. The force we're already given in our IJs and Ks. So that simply all we need to do then is our cross product. Remember, we leave our IJs and Ks up top for our reference. Then we have our R's are going to be in our top, and our F is going to be in our bottom. So we have R, we have 2, 3, and 4 in our IJs and Ks, 2, 3, and 4. And then we have negative 20, positive 10, and positive 15. We're going to do cross products between these. Remember, we take our I's, multiply across, minus, multiply across, and we do the same thing for our J's and our K's once we move this part over here. That is going to give us our MC, which will then be our MC over here as well. And those two, we would take dot products to find our U of AB.